Okay, last thing we're going to look at is the upper and lower bound rules. Basically, when you're doing synthetic division, if you are dividing with a number that is greater than 0, so let's say you're doing synthetic division with a 5. Since 5 is greater than 0, what happens is if your bottom row, after doing synthetic division, if your numbers here are all positive, then that tells you that you are not going to have any possible rational real zeros that are greater than 5. So that's why I was saying you want to try to pick numbers that are in the middle. So if I have, let's say, my potential list of zeros are 5, 10, 15, 30, and 60. If I divide synthetic division with 5 and my solution row is all positive, then that means I do not have to worry about checking 10, 15, 30, or 60. So this is a good way to list potential zeros. For the lower bound, if you divide with a negative number, then you want your bottom row to alternate signs. If you do synthetic division with a negative number and the bottom row alternates signs, then that tells you it is a lower bound. So if it's a lower bound, that means I do not have to worry about any numbers that are smaller than negative 5. So first thing I want to do to find all possible zeros is I want to do my P over Q. So my P is plus or minus 1, plus or minus 3, and on the bottom I have plus or minus 1. So my potential zeros are, we have negative 3, negative 1, 1, and 3 as a potential list of zeros. Now when I do synthetic division, I'm going to try the negative 1. But before I do it, let's check Descartes' rule of signs. For positive solutions, I go positive to negative, that's 1, negative to positive is 2, positive to negative is 3. So I can either have 1 or 3 positive solutions. Now to check for negative, I change signs. So this will end up being a plus, and the positive x ends up being a minus x. So I go positive to positive, nothing changed. Positive to negative is 1, negative to negative stays 1. So right now, I know I have one negative solution. So what I'm going to do now, which means imaginary wise, I could have 0 or 2 from this combination right here, 1, 1, 2. So first thing I'm going to do, since I know a negative is going to work, I'm going to try synthetic division with negative 1. So I got negative 1, and plus if it doesn't work and my bottom row alternates signs, I can get rid of the negative 3. So I have a 1, a negative 3, 0 for the x squared, a 1, and a negative 3. So I got 1, negative 1 times 1, fell at the bottom. So after doing synthetic division, notice I do have a remainder of 0. But now I have my new row factors, but now this is a x to the third power now. Now I don't have to worry about checking negatives anymore because I found my negative solution. So that's done, that's done. Now I got to work on the 1 or 3. I'm going to check the 1 because if I do synthetic division and my bottom row is all positives, I don't have to worry about the 3. So when I do synthetic division with the 1, I get the following. So when I checked 1, notice my bottom row did not have all positive signs, so 1 doesn't work. So that means 3 is probably going to end up working. So let's try 3. When I try 3, here's what I end up with: a 1x squared minus 1x plus 1. Now, since I did get a positive solution that worked, then that means I am going to get, there's my at least one positive solution. And let's see if we can factor it. If I can factor it, I need something that multiplies to give me 1, but adds to give me negative 1. And that's not going to happen, so I'm going to have to use quadratic formula. When I use quadratic formula, I get the following. So I get negative, negative 1, plus or minus, well, I'll let you check it out. And I get 1 plus or minus the square root of 1 minus 4 over 2. I get 1 plus or minus the square root of negative 3 all over 2. Pull out the negative and replace it with an I. So I get 1/2 plus or minus I times the square root of 3 over 2. And since nothing reduces, that's all I'm left with.